often you'll hear people talk about such and such going on, quote, the mainframe. And then they'll show a picture of it and you'll see all sorts of things, big Unix systems, mini computers, but that's not what we're talking here.
Now, you said you're a pilot. Are you currently flying?
Yeah, I'm a pilot and, really small aircraft owner. It's one of my big loves in life. I've been flying since the 1980s. So, I get a thrill out of that. My oldest son and our grandson live in, still live in that New York area. So, for us to go visit him is, 10 hours driving. It's close to that to take commercial airlines because everything's connections and all of that. But for me to jump in the airplane and get myself up there is, generally 3 hours, maybe a little less sometimes. So
it's a lot cooler too.
Yeah. Well, you get to come and go on your schedule. You get to, you don't have to deal with LaGuardia or JFK. You pick, whatever small airport you want to use. My airport here, I actually live almost walking distance to it. So it's, it's only about a mile away. So it's literally climb in the car, drag all the stuff to the airport, load the plane, put the car in the hangar, get in the plane, and you're in the air 20 minutes later.
See your grandkids.
Well,
nice.
One grandson so far, but he just turned 3, and it's a wonderful age to at least feel like you can be engaged and all of that with them.
100%. Yeah, my daughter just turned 6 this past week, and I had one of my first conversations with her, in the sense that I guess more mature conversations with her, because we were talking about how she was reacting to certain situations and what she could work on, and like a personal development conversation. She's like, yeah, Dad, I understand. She's like, I really can improve on that. And I was like, that is the coolest thing. Cause all the conversations from age 3, to 5 or whatnot, they're just general, everyday living conversations. But this was like a personal development conversation that I had. And I told my wife after, I was like, this is the best ever.
Well, give it another 5-10 years.
Oh, I don't want to. I can see it coming. Yeah, she's 6 going on 16. I can see it happening. I'm thoroughly scared. So it'll be an adventure of a lifetime. And my son's more predictable. He'll just punch me all the time. It's like living with a ninja. But we're going to talk about mainframes. Curious about I guess I'll ask a very specific question since we had a little bit of time to think about it yesterday and so on. But what's the difference between a mainframe and a server? How are they different?
Yeah, well, in today's day and age, I'm not sure there's a huge difference. I mean, the mainframe is a really, really big server. And it's you make an interesting point too. I mean, mainframe computing is, I think of it as one of the crown jewels in IT. High percentage of the world's largest commercial sites, government sites, so forth. They do a lot of processing on mainframes, and yet, not a lot of folks know these systems in any kind of depth. I used to do guest lecturer stuff with one of the universities. And I remember walking into a room full of grad students. I mean, these are master's and PhD candidates and computer science. And so you would think experts. And one of the questions I would ask to start the class is, how many of you have ever, seen or heard of mainframes? And, I taught this class probably 4 or 5 times, and I never saw a hand go up when I asked who knew anything about mainframes. And yet, I don't know, 80% of the world's commercial data probably traces its way back to a mainframe one way or another. So, yeah, I mean, and the other thing there is it's a really interesting history lesson. I mean, today's mainframes trace their roots all the way back to the 1960s and work that IBM did back then. And, it's almost hard for people to kind of wrap their heads around is applications that were written even, 30, 40, sometimes 50 years ago continue to work, unchanged at the binary level on today's most modern mainframes. Now, certainly today's systems are vastly different in terms of technology. And mainframe has, pretty much all the same componentry that you see in any other platform. It can run Java, it can run, web applications, it can have complex networks, all the same things you find in any server there on the mainframe. It's just that they tend to be kind of out of sight and out of mind that way. And, when you look back historically, you see that a lot of the things that have kind of come along over the years as breakthroughs in computing were done like decades earlier in the mainframe environment. I remember, a funny story about that. I remember when Microsoft released the very first version of Windows NT, they were really bragging about its multitasking capabilities and the fact that you could have more than one processor core on it. Well, those features existed in mainframes in the 1970s. So, it's definitely a different approach. Definitely, different operating systems. Most mainframes, the customers we speak to are running IBM ZOS operating system, which is kind of its own little ecosystem, very different than Linux or Windows or anything else out there. But really capable platform. And in terms of capacity, a large mainframe is easily hundreds of times more capacity than even a large server would be in the Windows or Linux environment. So some fundamental differences, but at the end of the day, they run a lot of very similar workloads.
Okay, now I'm going to ask more pointed questions because you've given me something to go off of here. I'm going to be relentless about my personal understanding of a mainframe.
Well, it's good. We can win you over.
You can win me over. I don't even know what they are, so let's hope I can figure it out first.
Yeah.
All right. So IBM. So if I go buy, boards and a processor and a drive, and I basically build my own computer, and I put IBM ZOS on there. Is that now a mainframe?
No. Well, so first of all, you can't quite do that because way down at the processor architecture level, the mainframe is a different beast. It's not running on an Intel architecture or anything that's kind of off the shelf that way. It runs it's really its own architecture, so its own hardware instructions and so forth. And as far as I know, the only one who actually builds that hardware at the chip level is IBM, and the only place these things go is into the mainframes that they sell. So over the years there have been competitors, there have been Hitachi, there have been companies like Amdahl who have built their own hardware that implemented the mainframe architecture. But generally, you can do what you described and just kind of cobble it together. You buy kind of a completed system, typically from IBM these days. So, but other than that, I think if if there was a market and you could go buy a mainframe processor chip to plug into a motherboard someplace, then what you described is pretty close to the truth. The internal architecture of all the parts is different. There isn't today. No.
Okay.
I mean,
so
there are a few. I'll call them emulators. Basically PC programs that can pretend to be a mainframe, and they create that kind of a virtualization of the mainframe environment, so you can run that in software. One of the popular ones is something called Hercules. So that's what a hobbyist would typically do. You would cobble together what you described, a server with whatever componentry you wanted, you would run something like Hercules, and now you have a mainframe that you can kind of put your hands on. Be very small in terms of capacity. It wouldn't have all of the mainframe features. And probably the biggest problem you would have with that is you can't just go to IBM and say, I'd like to license a copy of ZOS and install that operating system on it. You know, they tie that software license to, you know, piece of hardware, and you know, certainly they wouldn't sell you that to run on something like a Hercules emulated mainframe. But you know, conceptually, you're in the right spot. It's just different internal architecture for all of this stuff.
Got it. So mainframe is not a brand, correct?
That is correct. I mean, it's
not a brand.
If you look in the movies, you know, often you'll hear people talk about such and such going on quote the mainframe. And then they'll show a picture of it, and you'll see all sorts of things, you know, big, you know, Unix systems, big, you know, mini computers, we used to call them. I mean, they're just kind of big and impressive because they have a lot of lights. They probably make it interesting to film. But that's not what we're talking here. Usually when people talk about mainframes, they're talking about, you know, IBM brands it as System Z. And, you know, there are, you know, dozens of different models that have been produced under that name over the past, you know, X years. So, you know, that's generally what we're talking about. And you would, you know, if we kind of wheeled one in for the podcast, and by the way, that's a great idea if you can get some, you know, artwork woven in, you know, people would probably love to see one of these things. They are not impressive. I mean, they look all the world like a commercial refrigerator or, you know, something like that. It's not like you might think, you know, this panel of dials and lights and knobs. And I mean, that existed in the 70s. That hasn't existed probably in, you know, at least 30 years now, though.
Yeah, I get most of my knowledge from movies. So they'll say the mainframe and they'll pan to it. I'm like, it's just the servers. I was like, they're just servers. It's just a normal rack. And I'm like, what is this mainframe? And so that's really helpful. Now let me continue to make some assumptions and have you correct me here. So mainframe is not a brand. Mainframe would be a specific type of architecture.
Yeah, I would think of it as you know, on a similar level to, I mean, you used the word server before. You know, when I say server, people tend to think of kind of rack mount things that are populated with Intel processors or AMD processors, but they, you know, run a certain kind of workload. Mainframe is kind of that, where we're talking about IBM System Z hardware and ZOS operating system and all of the things that kind of go with that.
Are there mainframes that are not IBM?
Well, so you know, putting aside the software emulated mainframes that we talked about briefly, there were 3 or 4 other hardware vendors in this space. You know, Hitachi, Amdahl, you know, a few others. Fujitsu has you know, nearly compatible version that they sell mostly outside the U.S. So, you know, there are those kind of things that generally get lumped into into that category as you know, mainframe. There, you know, in the 1990s, you know, these I'll call them alternate brands were you know, very, I won't say very popular, but they certainly had 20, 30, 40% of the overall mainframe market. Yeah, in the years since then, they've kind of dwindled. You know, IBM made a major leap in technology when they brought 64-bit processing to their mainframes. And at that point, it just got too expensive for a lot of the competitors to kind of stay in that space. So, you know, little by little, they've been fading away. I'm sure there's still some of those systems scattered around the world. We run into mainframe customers, especially outside the U.S., that have been running whatever they're running since the 1990s without really changing anything. So, I'm sure there's still some of those out there, but the kind of mainstream mainframe would be, what we describe would be IBM's processors, operating systems, and all of that stuff.
And would workloads be able to shift between manufacturers? Like if I had a Fujitsu one, and then is that architecture identical to the IBM architecture? Is that like open architecture that they're aware of and they can recreate? And can the workloads be moved between them seamlessly or no?
Yeah, I mean, and that's basically what kind of spawned this competitive thing back in the 1980s. You used to see that, IBM published very detailed specifications about the architecture. In fact, their operating system was one of the first examples of, what today we call open source. When I was kind of a youngster coming up in this space, if I had a really deep question about how the operating system worked, I kind of walked down the hall and we had this cabinet of microfiche, and on that microfiche, and people probably don't even know what microfiche is anymore, but it was basically the source code to all of the operating system. So it was there, and that meant if you were a competitor, you had kind of a pretty clear path to understanding how all of this stuff worked and all the fine print of the architecture. At some point, I think IBM felt that, and I would feel the same way if I were a shareholder of IBM, that's a lot of intellectual property that needs to be protected. So little by little, it became, trademarked and patented and so forth. And now probably all that same information exists. It's just that first you have to go license it from IBM. And of course, if you're looking to build a competing mainframe, that's going to be a really, really expensive thing to license from them, or they might just refuse to do it outright. So the foundations are there. You can understand that mainframe architecture in an incredible amount of detail, much more. I'm one of the rare people. I've developed commercial software on mainframes, on Windows, on Linux, on lots of different platforms. And I have to say, it's not even close. If I want to know some detail about how the mainframe works, it's much better documented. There are better tools to help you understand it. All of that. I can understand kind of the internal workings of the mainframe way better than I can understand the internal workings of, let's say, a Windows server. So it's, it created an environment where it was easy to compete because of all of this stuff, and that's what we saw, back in the 80s. And the value prop for a lot of these companies was that they would give you 20% better performance for 20% lower cost. So, they were able to, lure a lot of business away from IBM that way. And the only way they could do it, to kind of circle back to your original question, the only way they could really do it was to show that they were absolutely 100% compatible. You could run a particular program on the IBM hardware, take that exact program, run it on, the brand X hardware, and it would process exactly the same way. Maybe a little bit faster, maybe the cost would be a little lower, but the results would be the same. So that's an important part.
Do you believe that applications within the ecosystem were written with more stability and better performance because of the access to the source code of the operating system?
I mean, in some cases, yes. It's a lot of things, though. I mean, in the earlier days of, mainframe computing, it wasn't uncommon for folks to write, even large applications in assembler language, the low-level language that the hardware understands, where the programmer is writing, one for one, here's a hardware instruction, one after the next after the next. And the big software vendors, that's still how the world is. And I compare the efficiency of that to, let's say writing let's say a Java application that runs on the mainframe. It's night and day. I mean, a well-implemented assembler language routine running on, modern mainframe hardware is going to be, just light years faster than trying to do that same algorithm in Java or C or C++ or whatever other language you have. So I think, in those days, I mean, it's important to understand. I mean, a lot of those earlier mainframes, we measured, disk space in megabytes, not terabytes. So, and memory was, K, not terabytes. And, so, when the business required, I need this particular function and it's got to fit on a 4K page or whatever it was, your options were pretty limited. You didn't really see a lot of high level language use in the earliest days of the mainframe. That came with time, and like I said today, all of that exists pretty much the same on mainframe as other platforms. It's just much more of that legacy code is still the more efficient stuff versus the new applications that are showing up there. You also had a really interesting thing there too. One of the ways I kind of started out was I worked on what became one of the first commercially viable cybersecurity products for the mainframe, and we needed to do very low-level things inside the operating system. So, as an example, when you open a file, we needed to insert some logic there that said, are you allowed to open this file? And,
always.
Exactly. So, being able to understand kind of the little gory details of how the mainframe operating system was working was a huge enabler to that. It would have taken a lot of trial and error work to figure that out, without at least a little bit of, insight into, kind of the structure you could get from the source code and so forth. And, honestly, in my mind, that's where the software industry comes from. Before the period of time that I'm talking about, all of the software came with the computer you bought. So you went to IBM, you bought one of their mainframes, and it came with all the compilers. It came with, pretty much everything you needed to run your environment. There were a few small upstart companies after that who had the idea that, well, if I did a better, fill in the blank cybersecurity product, people would pay me money just for that. And that created the software industry. This was well before the PC came along, and it, continues today. It's an important, development in how kind of the industry thought about, what's the role of hardware and software and how does it get packaged together, and, what vendors can do what, and, all of that stuff. So, interesting archaeology exercise.
Yeah. So the architecture of the chips, that is one key differentiator between just building it my own compute and storage, and then buying it, owning an actual quote unquote mainframe. Capacity you've mentioned a couple times too. So that's one big difference. The architecture is a huge difference, but you've mentioned capacity is a big difference. Can you explain to me how the capacity of the mainframes are different than the capacity of, let's say, something I could flip on at AWS?
Yeah, I mean, so mainframes are a little bit different in how they're sized and what their capacity limits are and so forth. One of the really key differences is that, for that architecture we're talking about, I might have, one physical cabinet that's got a bunch of processing and memory installed into it. And Unlike most Intel systems, a lot of that is dynamically reconfigurable, sometimes based on a command that the IT operation folks enter into the system. So, it's not a fixed capacity. In other words, it's a varying capacity based on what your workload requires. And the big underlying reason for that is all about cost. It's not that there's today we look at Intel processors and whatever the hot CPU is today, it's got a certain price and a certain set of capabilities, and we recognize that. Everybody understands that. Mainframe isn't like that. There might be 3 or 4 different models, but within that, there might be 100 different capacity settings, depending on how big your workload is. So if you're, a big retailer, you might spend most of the year with that capacity dialed back, so your costs are pretty low. And then maybe in that period from Thanksgiving to the end of the year, you dial it up, and without any physical change in the box, now you might have double, triple, 10 times more processing capability to handle, the business transactions that you get then. So, and of course, if you're, a large company like IBM, you create a whole marketing structure around that. So it's sold that way to the customer. It's, very dynamic to kind of meet his needs. And, that's one of the real key differences, is that you can very easily size the hardware to the workload that you got. And even if your workload varies all over the place, you can keep up with that pretty easily without continuously doing hardware upgrades. The other thing, too, is just the way we think about mainframes is, things like fault tolerance are really important. I want to be able to have, almost, you would think of it as clustering in on other platforms. I want to have multiple mainframes that connect together, work together as though they're one system. So that's kind of another way I can scale these systems. I can have, one standalone mainframe. That's probably fine for a lot of smaller clients. I could have 32 mainframes in a, single cluster, and to, external users connecting into these systems, they see that as one system image. They see it as, one cooperative thing that shares resources. So, you have that kind of scaling as well. And then, of course, virtualization, just like you have in the AWS cloud, is possible on the mainframe. So that one mainframe device, that one system Z server, the physical thing, can be carved up into lots of virtual servers. So you might run, a production workload and a test workload and a development workload, and whatever your needs are that way. And it all adds up to, just a different way to think about the virtualization that way.
So there's not a large difference in capacity, how we look at capacity between the two systems.
Yeah, I mean,
it's mostly architecture.
Look, when you're dealing with small numbers of systems, of course, you have to have massive capacity. So, an example of that is, I can have 9,600 gigabyte network adapters on a single mainframe. You don't see that on, Intel-based servers. But on the Intel server, you might have, 1,000 rack mount servers. And, in aggregate, it's, you can certainly build the capacity that way. Much harder to do off of the mainframe, right? Because you have to design your software to really take advantage of that type of scale. Mainframe tends to be, way easier to do that stuff. It's just, we used to struggle with this quite a bit on the software vendor side. How do you do, even things like pricing that are fair to everybody? Some users might scale it down really small, equal to just a couple of servers. Some might scale it up to the equivalent of 1 million servers. You can't charge the same price for that. So, it creates
Is it
complexity
the same
in the
amount of
business
hardware
domain.
though?
I mean, no, it would not be the same amount of hardware.
Yeah,
It would be
right.
one box or handful of boxes, physical things,
Okay.
versus racks and racks and racks and racks of Intel servers. But
So just charging for dynamic usage was what you guys were trying to figure out then, right?
yeah, I mean, a lot
Yeah.
of software in the server world is sold per device. So every server I have, I charge $1,000. When your mainframe can go from 1x to 800x inside the same physical footprint, it's hard to do it that way. You have to have some other metric to either not give something away or not have to overcharge so much that the small customers won't accept that. So yeah,
These small customers were connecting into mainframe clusters then, and it was like multi-tenant. Is that what you're describing?
I mean, it certainly could be that. I mean, there were all sorts of things. I mean, we saw, on the small side, you would see things like universities or, smaller companies that had mainframe applications, maybe for, legacy reasons that they just needed to keep running. They might just need a small amount of mainframe capacity. That's really different than, I don't know, a Citigroup or, someone like that who's doing, millions of transactions a second on their mainframes. So, really just depends what your workload is all about.
So how you design your strategy for capacity is a key differentiator between mainframe and not mainframe.
Yeah, no, absolutely.
true?
And,
Okay.
in this day and age, a lot of that really just comes down to what's the best way to achieve low cost per transaction. In fairness, mainframe is such that if you don't have a big problem to solve, it's probably going to be too expensive for you. If you have a handful of users and a handful of transactions, mainframe is going to be really, really expensive. On the other hand, if you have massive workloads, maybe you're an airline doing a reservation system or a big banking system or, something like that where you're
Okay.
processing a gazillion transactions, the cost per transaction on the mainframe is going to be much less than most other platforms would be.
So because of its efficiencies.
Yeah, well, and I mean, that's a core part of it, but it's also things like it's always easier to manage, one big thing than lots and lots of small things. The one big thing, you put some policies in place and it kind of takes care of itself. The large collection of small things is complicated. You have a lot of interdependencies and connections and network issues and, 100 things that can go wrong there that just can't go wrong on the mainframe because you only have one of them or, a small number of them. So, that has the effect of driving up like your management costs. And then you think about, well, how am I going to do fault tolerance? How am I going to do, react to spikes in workloads and, all of that kind of stuff. And, generally those kind of things are just kind of built into the mainframe architecture. There are absolutely ways to do it on other platforms. It just, they tend to work out a little bit more costly on a per transaction basis.
Okay. So on the mainframe, if I exceed let's say I'm a airline and I have to purchase for the greatest capacity I'll ever experience at the highest point in the season, correct? As far as number of mainframes?
Yeah, I mean, I guess the best practice there would be that, you would sit down and this isn't something you're doing every day. So you want to make sure you're correct. And, there are, designated experts in a lot of sites that are doing this kind of work. And what they'll do is they'll project out over, whatever their buying period might be. Often it's, a 3-year kind of time horizon. And they'll say, okay, over that, we think here's where our peak workload is going to be, based on, business conditions and all of that. And then they'll look at what's the cheapest way to do that. Is it, multiple data centers in one big data center? How many mainframes? There'll always be a sweet spot in terms of the the costs to handling that workload. And that's what they'll put in place. They'll go contract with IBM and all other software vendors and, all of that to put a price in place. And then they kind of just execute against that plan for, however long it's in place. Now, certainly surprises happen. If you're, that big airline and there's a sudden spike in travel activity or, whatever it is, regulatory change, whatever it is, and you need, you realize you're going to be 20% short on capacity. Yeah, I mean, you deal with that kind of as you go. But, the important thing is you tend to see that coming. And there are really good tools in this space on the mainframe that help the capacity planner understand, what the trends are, and if there is something unexpected, is it just because you implemented some inefficient software that could be done better? Or are you truly handling more transactions than you expected to handle? So, again, it's an iterative thing and you have many options. You might sit down and say, maybe we shouldn't have rewritten that older COBOL program in Java because now it's taking too much processing power. But, if you go through all of those options, the most direct thing to do is add capacity. It's generally a matter of, just paying for that and activating it. And again, the mainframes are so dynamic, there's no changes generally for that. You have the, good folks at IBM activate that extra capacity inside your box. You kind of wander over to the machine, push a few keystrokes, and now your system got bigger. So, totally non-disruptive. It's not like you even have to, reboot the systems in any way in a lot of cases like that.
It's very cloud-like then. So
yes.
So then me being on the outside of this and only have written business logic, Ruby on Rails, PHP type code for the majority of my software career. So that's my experience. So when I'm looking at it and having a conversation with you as an expert has been eating, sleeping, and breathing this stuff for 30 years, right? And I'm trying to understand the differences between the environment I grew up in and what people are calling this mainframe. The key difference that I'm going to walk away with, and so you're going to have to correct me before I do walk away, but the key difference I'm going to walk away with is that because of the architecture that is implemented on mainframes, people write applications that are more efficient, which at scale will create a better cost per transaction. So these large companies use these mainframes because of it's just the most cost efficient way to do things.
Yeah, I mean, that's largely true. I mean, I would not discount the fact that a lot of it is just facts on the ground. If you're a big insurance company, you have a portfolio of thousands of mainframe applications, and the cost of redoing them to run that workload somewhere else there's just no business value in that. So you just kind of keep going with what you have that way.
Oh.
So,
okay.
I mean, if put yourself in the shoes of the CIO at a lot of these sites. He's got something that, it's running, it's been in place forever, it's, meeting their business needs. I mean, he's not going to dismantle that just to say, it's in the AWS cloud or something. He needs a important reason for that. And, and I'm not saying that doesn't exist. He might have a good reason for doing that. He might, he might look out over his mainframe staff and they're all kind of my age, early 60s. And, he might look at that and say, in 5 years, who's going to do this work? And, that might be the motivation to take him to, some other platform. But, just for doing it for the sake of
cost.
doing it. Yeah.
As the people retire, there will be a smaller number of people that know this technology, and then they'll become higher in demand, and that cost will raise to a point where it might make sense just out of bandwidth of being able to make changes to your system to move the systems.
Yeah, I mean, you would think that, and and it's funny you make that observation. I actually wrote a big research paper on this many years ago because it was one of the things we were very concerned about. Where the skill's going to come from in the future. It's not like most American universities have programs in mainframe computing anymore. And in fact, even the professors, if they wanted that, they couldn't teach it today. There just aren't folks who know this space in that academic world anymore. So, and I don't mean that as a wholesale statement. I mean, I don't want to get comments from
we're gonna bill it as a wholesale statement. That is the official view.
Yeah, but
No, cool.
the point is, it's definitely
uncommon.
a source of concern. But on the other hand, if you look at it, what you said is very is a very good observation. You would expect that the laws of supply and demand would step in that case, and as folks kind of hit that retirement age and the pool of folks with mainframe talent shrinks, you would expect wages to be going through the roof. You would expect, all sorts of things to happen. And, just to go past that, it would eventually be self-correcting. People would look at it as, I've got my computer science degree. I can earn X as a, web developer somewhere, or I can earn 2X by going and doing mainframe things. So eventually that would tend to balance out. I can tell you that's not happening. If I go back and I track inflation adjusted wages for mainframe developers from the year 2000 to now, it's less growth than you see in most other areas. A PHP developer, for instance, their wages have inflated more in the last 20 years than a mainframe developer has. So, I think what that really comes down to is if this is a trend, it's a trend everywhere. And there actually is more demand for, all of the other skills we're talking about versus mainframe skills. Another thing that you see in the mainframe community is, for all the reasons we were talking about, you tend to be able to run a large mainframe site with less staff than an equivalent amount of capacity in a non-mainframe site. So, there an example, a customer that I used to be pretty actively engaged with. When I looked at his mainframe team, the whole thing, top to bottom, 20, 25 people. The non-mainframe side of his business was closer to 500 people. So the truth seems to be it's just, people are finding ways to bring new skills in because it's not like you need hundreds of them. You only need, a relative handful of them by comparison. And I think that's what's helping keep the kind of skill balance alive and really across the industry. We saw it, I spent many years at CA and we had this fear, quite a bit, where would our future stars come from? The folks with really deep mainframe technical skills. And, we did what any business would do. We invested, we created a couple of new programs, new development centers. We staffed them with, younger folks. And we made the conscious business decision that we were going to spend maybe 3 to 5 years training them and grow the skill that we needed organically. And, that would serve our needs for, the foreseeable future. I think a lot of the larger mainframe sites are kind of going that way. Now, if you're a medium-sized or small site, maybe you have the option to do that. And maybe you are really concerned about the skill issues here. So, it's not really a one-size-fits-all answer, but it does seem that what you would expect as kind of the economics of supply and demand for mainframe developers isn't really behaving the way you would think it does, and in the at least in the first cut.
Yeah, I'd say I look. I don't have a dog in this race, but I would think that there. I agree with all the points you made. I don't think any of them are wrong. I'm interested. Here's how I can say this. I'm interested to see what happens in the next 20 years with that wage growth, largely because there is a component to a lot of these people starting their career and then living their career out for 30 years. and the dynamics of just what's happened in our country with the finances, as far as, buying homes at a lower cost per total salary, living in those homes. There's just a different mindset of people in their 50s and 60s than there are today of this generation. And so I think that from your research, if we haven't seen a large growth change, that we're maybe a decade or two away from seeing it, because then you get more people retiring, and then you're just gonna have that need. I think, I've had one conversation with a while back ago. I'm pretty sure we didn't air it because of some reason or another, but it was a major public utility company in a state which will go unnamed. And they had a problem with their systems, and they looked around and they realized that they knew nobody in the industry that understood how these programs were written. And they were down, and they just had this huge issue. So they started calling all these retired guys and pulling them in as consultants, trying to get them to help. And so I thought that was fascinating, that can actually happen. But the worst case we can do is, you can, as CA did, they can hire a bunch of people. We could also go to the retirement homes. We can start a little business together, my friend Vince.
There we go.
Go to the retirement homes, and we can train Chat GPT. We can Neuralink up the older people, have it train Chat GPT, and then now we can have one person run the entire mainframe.
Yeah, well, the other thing that's important here is the skill level is different today than in the past. When I was kind of coming up in this space, no matter what your role was, you generally had kind of, today we would think of them as very deep skills. You knew how to write, assembler language, the language of the machine. You knew, not just how to administer things, but how things actually worked underneath and how to take advantage of that. Over the years, it's not really just IBM. I'll give them a lot of the credit, but a lot of the software vendors too have just automated so much of that out of these systems that the need is different today. Today it's more about how do I administer it rather than how does it work. And, because of that, I think that also has been a big help in the skill issue that we're talking about. Plus the other thing too is that, one of the things that helps on other platforms is, the whole offshoring idea. The fact that I could have, 200 developers tomorrow sitting in, some country like India. All I have to do is pay for it. I can do that very easily with mainframe developers. For whatever reason, those skills just never, blossomed in a lot of the places where you find low-cost offshore talent. So, that just creates a different dynamic than what we've seen in other places. I want a website build, with the technologies you mentioned, PHP and, MySQL and, all of that. I mean, I can do that anywhere. I can even crowdsource that. I don't have to do it, in a formal kind of a way and have employees for that. Can't really have most of those options with mainframe applications, even though a lot of those same technologies exist in the ZOS operating system and they sort of work the same way. It's just not, a common environment that, people have access to or would feel comfortable that way. Funny example of that, one of the projects we worked on involved a little bit of open source. And, we looked at the open source and it didn't support the mainframe operating systems. So we decided we would do that. We took a snapshot of the source code. We enhanced it so it would run fine on ZOS. And, we were pretty happy with it. And, at the end of the project, we figured we would just turn what we had done back over to the original developer, and he could, carry it forward as new releases came along and so forth. He refused to take it from us. And his rationale was, I don't have a mainframe. I don't have any way to test that in the future. I don't have any way to know what works and what doesn't work. So yeah, that kind of work sometimes gets orphaned that way because you just don't find, a broad skill base there the way you do on some other platforms.
Well, I'm watching time. I want to make sure that we get a little call to action in for what you guys are doing over at your company, VirtualZ. Can you just give me the 30-second why VirtualZ exists, what problem you solve for the mainframe?
Yeah, I mean, VirtualZ is all about making it easy to, share that data that's on your mainframe with other platforms. No matter what you're doing with the mainframe, the reality is, today every business has mainframe and other things. And, one of the critical needs there is how do I get data out of my mainframe and into, wherever I need it? It could be an AI tool. It could be, God knows what. And historically, that's been a hard thing to do. It's been, file transfers and FTP and all of that kind of stuff. Well, what we do in our products is, and really there are two key products here. The first product is about leave the data on the mainframe, but make it easy to make it accessible from anywhere you want. So, we make all of that mainframe data look like a big network drive in the sky, and you can consume it from just about any application. Number two is kind of the opposite of that. It's, I got the application on the mainframe, and it needs some data that I'm producing in a cloud application or in, whatever it is, it's not on my mainframe. So, I want my existing mainframe application that was maybe written 30 years ago to be able to read and write data in, let's say the Amazon cloud or Azure or Google or, wherever it happens to be. So that's kind of the problem that we solve for customers. And, and it's a funny thing. We know how to do this for, a decade now on other platforms. If I'm running a Windows server and I need couple of terabytes of storage, I don't even think twice about that. I go to Amazon, I go to Dropbox, I go, wherever I want to get that storage, and I use it, and that's not a particularly novel thing to do anymore. Mainframes have never really participated in that, and that's what we enable today. We enable any mainframe customer to leverage low-cost cloud storage, share information across whether the application is a mainframe application using cloud data or a cloud application that needs mainframe data. We make it just drop dead simple to do all of that. Saves the customer a huge amount of time and money having to figure out how to get data from A to B. We guarantee that it's all done in a secure way and with a lot of integrity so that you don't break other applications that might be referencing that same data. And it feels like an important requirement that mainframe customers really struggle with today.
Nice, and that's VirtualZ. We can put a link in the show notes, and man, that's it. We did it. We made a podcast. Wow. How do you feel, Vince?
Yeah, no, you made it relatively painless. How do you feel is probably a better question, though.
I feel like I got my questions answered. I honestly feel I came into this conversation not knowing what mainframes are. Somebody asked them. I would say they're the big ugly servers. That's what I'd say. They're the ones that you can walk like into and through like a giant room. But now I have a good understanding of what the difference between what I know as a server, storage and compute being processed, right? Working together. And what a mainframe is. And I'm going to walk away with the architecture aspect and the efficiency because of the architecture and then the business models of the companies put these systems in. They're efficient. They handle tens of millions, if not billions of transactions flawlessly. And the cost just doesn't make cost sense to rewrite them in the cloud when everything's working currently. So now we have basically as a society, we've got these systems. We can call them legacy systems or mainframes or whatever we want to call them. But we've got these systems and we have to at least give the ability for these companies to stay relevant. And that's why a product like VirtualZ would be interesting, because now rather than having to face, we need to rewrite the whole systems and all this cost just to get this one ability that we really need to make the data accessible, or We need these mainframe application developers that are really, really rare, or, there's not a lot of talent out there that are building these to make this custom connection. Like why build your own connection up to these services when you can just use a product like VirtualZ? I mean, that makes sense.
Yep. No, that's a great recap. You were paying attention.